In today's class, we're going to be considering some exam questions on this concept, velocity time graph. Okay, let's start with the first question. If a car starts from rest and moves with a uniform acceleration of 10 meters per second squared for 10 seconds, the distance it covers in the last 1 second of its motion is dash. Okay, let's draw the velocity time graph. Okay, don't forget that the question says the car starts from rest, you understand, and it accelerates for 10 meters per second squared. Please, I want you to pay attention. Okay, we've learned in our previous class that if we have a car that starts from rest, the velocity time graph will look like this, you understand. Okay, so because the car starts from rest, let's have the velocity time graph. Let this be v, and we have t in this place, you understand. Okay, now we are told that the car starts from rest and moves with uniform acceleration of 10 meters per second squared. So because the car starts from rest, we are going to start from origin 0, 0, you understand. This is the origin, you understand. So it starts from rest, it's going to move like this, okay, for 10 seconds. So the distance between this point to this point, let's call this one 10 seconds, okay. This is too high. Let me increase this as well. I'm just trying to draw, interpret the question, you understand. So by drawing out the diagram, okay. So this will be 10 seconds. Let me reduce this also as well, okay. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You understand? And we are given that acceleration A equals to 10 meters per second squared. Okay? Now, the car starts from rest. If the car starts from rest, what will be the initial velocity? The initial velocity will be 0. You understand? Because the car starts from rest. That means that u is equals to 0. Okay? Now, I think those are the parameters that were given in the question. Now, please, I want you to pay attention. We cannot determine the distance is covered without knowing the velocity that it attains for 10 seconds. You understand? Please pay attention. We cannot determine the distance that is covered in the last 1 second without knowing the velocity that is covered in the 10 seconds. Are you paying attention? So I'm going to calculate the velocity. Do you understand? And since I have known that we are given that the car starts from rest, from the equation of motion, the first equation of motion says v equals to u plus at. That is, the final velocity is equals to initial velocity plus the product of acceleration and time. You understand? Now, for this, v equals to 0 plus at. A here will be what? 10. 10 multiplied by t. T is what? 10. You understand? T is 10. So 10 multiplied by 10 will be what? 100. So v is equals to 100 meters per second squared. You understand? So the velocity at this point, is what? 100 meters per second squared. Okay? 100. Okay, this is meter per second. Oh, sorry. Velocity is in meter per second. Okay, sorry. So the velocity at this point is what? 100. Okay, 100 meters per second. Now, please pay attention. You know that the question says we should calculate the distance is covered in the last 1 second of its motion. That means that distance will be the distance between the 10th second and the 9th seconds. You understand? I will repeat that again. Okay? We are told to calculate the distance is covered in the last 1 second of its motion. That distance will be the distance between the 10th seconds and the 9th seconds. You understand? So I will calculate the distance for the 10th second separately. I will calculate the distance of the 9th second separately. Then I'm going to take their positive difference. You understand? That will be the distance is covered in the last 10th seconds. Do you understand? Okay? Now, but this velocity is for the velocity is attained in the 10th seconds. Okay? V 10th. This is the velocity that is attained in the 10th seconds. Now, we can determine the velocity that is attained in the 9th seconds. How do I do that? We are still going to make use of the equation of motion. You understand? The velocity that it attained, that the car attained in the 9th seconds now. 9th seconds. V9. Okay, let me just put it V9. Please pay attention, okay? V9 is equals to U plus AT. So V9 is equals to 0 plus A. A is 10. T is now what? 9 seconds. You understand? You know, when I want to determine the velocity that the car attained in the 10 seconds, acceleration is 10 and time is also 10. You understand? But I want to determine the velocity that the car attains in the 9 seconds. That means that T will be what? 9. You understand? So I'm going to have this multiplied by 9. So V9 is equals to 90 meter per second. You understand? So this is 90 meters per second. It will be around this place, 90. Okay? So let me just sketch this down and then let's have something like this. You understand? So now we can easily determine the distance that the car covered in the last 1 second of the motion. How do we do that? We just have to take the area of the shape that we have on this board. You understand? And the difference will give us the distance that is covered in the last 1 second. Okay? So let's start. What is the name of this shape? Please pay attention. What is the name of this shape? We have something like this. For the 10 seconds, okay? We have this, the first shape. And we have another shape. We have two shapes in this velocity time graph, okay? We have another shape. We have another shape that looks like this. Sorry, I'm not really good at drawing. You understand? So we have the first shape and this is the second shape. The first shape is the bigger triangle. You understand? That will, from this point to this point is what? 10. So we have 10 here. And from this point to this point is what? 100. Please pay attention. Listen. We have two right angle triangle in this shape. The first one is this. The first right angle triangle is this. You understand? Please pay attention. The first right angle triangle is this. You understand? And the base from this point to this point is what? 10. That's why I have 10 here. Okay? And the height from this point to this point is what? 100. That's why I have what? 100 here. Okay? Now, let's look at the second one. The second one is this is the triangle. For the second one, we have this. From this point to this point is what? 9. So I'm going to have 9 here. And from this point to this point is what? 90. So I'm going to have 90 in this place. Do you understand? Now, the distance that the car covered in the last 10 seconds will be the difference between this area and this area. You know that in velocity time graph, the area of the graph give the distance. You understand? So if I want to calculate the distance that the car cover, I'm going to use the formula of a triangle. You understand? Let's calculate the area for the first triangle. I'm going to have area. Okay, let's call it distance now. Okay, distance. The distance here equals to half base. Half multiplied by 10 times 100. You understand? So for this, I'm going to have 2 here 1, 2 here 5. 5 times 100 is what? 500. So this will be what? 500 meter. Okay. Now, for the second triangle, that will be the distance also. The distance is equals to half base times height. The base is 9. So I'm going to have multiplied by 90. You understand? So for this, I'm going to have 2 here 1, 2 here 4.5. 4.5 multiplied by 90. That will give us 405. Okay. So this is 405 meter. Okay. Now the distance in the last in the 10 seconds, that will be the distance in the 10 seconds. 10 seconds. That will be 500 meter minus 405 meter. That will be 500 meter by minus 405 meter. That is 95 meter. You understand? So that is the solution to the question. Trust you understand. If you do understand, reverse the video and listen to the explanation again. Okay? Let's have the second question. A body which is uniformly retarded comes to rest in 5 seconds after traveling a distance of 10 meters. What is its initial velocity? Okay, let's draw the velocity time graph. Don't forget that in our previous class, I told you that when a body comes to rest, the velocity time graph will look like this. You understand? Okay, that is the body retarded, it's coming to rest. It has a significant initial velocity before. You understand? For example, you can have a car moving with a velocity of 10 meters per second. Then the body comes to rest, and come to rest means it retards. You understand? The velocity begins to decrease slowly till the body comes to rest. So the velocity at the peak here is the initial velocity now. You understand? Are you paying attention? Because the body is moving with initial velocity of 10 meters per second now. I'm just assuming, you understand? So the velocity we have initial velocity we have a significant figure because the body comes to rest, and comes to rest means that it's traveling with a particular velocity before. That velocity is what we call the initial velocity. Do you understand? Okay. So when the body comes to rest, the velocity time graph look like this. Do you understand? Okay. Let's go back to the question. A body which is uniformly retarded comes to rest in 5 seconds. Let's have the velocity time graph, okay? We have V and we have T. V in meter per seconds and T in seconds, okay? Now, the body which is uniformly retarded comes to rest in 5 seconds. So, since it comes to rest, the velocity diagram will look like this. Do you understand? So, this will be what? 0. And because the question says that the body comes to rest in 5 seconds, so here will be what? 5. Do you understand? So we are told to calculate the initial velocity, and they gave us that the distance covered is what? 10 meters. So the distance covered equals to 10 meters. How do we calculate the initial velocity? Please kindly pay attention. The initial velocity of this body is the height. You understand? You see, the parameters that you are given in the question will define what you are going to use. I pay attention. We are given that the distance covered is what? 10 meters. Now, in velocity time graph, the distance covered is the area of the shape. You understand? Area of the shape that we have in our velocity time graph is the distance covered. Now, what is the name of this shape? The name of the shape is what? Triangle. And the formula for triangle, area of the triangle is given by half base times height. You understand? The height there is the velocity. You understand? This is the height. Is that not it? The height is on the y-axis. You understand? And if the height is on the y-axis, that means velocity is also on the y-axis. So the distance from this point to this point is what? Is the height. That is what I'm looking for. Now, if I get the height is the velocity, and if I get the height of this triangle, that is the velocity of that triangle. Do you understand? If you understand, listen to the explanation again. In velocity time graph, the distance is calculated using the area of the shape. You understand? The area of this shape is half base times height because we are dealing with triangle now. Is that not it? Now, having known that we are dealing with triangle, half base times height. Height in velocity time graph refers to the velocity. You understand? Height in velocity time graph refers to velocity because in velocity time graph, the velocity is measured along the y-axis. So this is velocity, and this velocity is the initial velocity. You understand? Because the body is coming to rest. Okay? So let us calculate the initial velocity. The initial velocity is the height. Initial velocity u equals to h. You understand? And the area of a triangle is equals to half base times height. Is that not it? Like we did in the previous question. So I'm going to have 1 over 2 multiplied by base, which is 5, multiplied by height, which is h. I don't know the height. The height is also the same thing as v. Or let us represent as u. You understand? The height is also the same thing as u. You understand? So area has been given. So area is what? 10 meters. So I'm going to have 10 equals to half base times height. Do you understand? So for this, I'm going to have 10 equals to 5u all over 2. You understand? Now I'm going to cross multiply. 10 multiplied by 2 is 20. So I'm going to have 20 equals to 5u. Divide both by 5. This over 5 and this over 5. That means u equals to 4 meters per second. You understand? So that is the initial velocity of the body. Of the canal. Body is we are dealing with body. So that is the initial velocity of the body. You understand? Please, do you understand the explanation? If you didn't understand, listen to the explanation again, okay? So that will be all for this class. See you in the next class. To watch the next class, kindly check the description of this video. You are going to see a link there. Click on that link, or you should check the playlist on this channel, okay? See you in the next class.